Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I am your instructor, Jim Herby. In this episode, we're going to continue in Module 5 in the exam objectives and discuss Section 5.2, Database Features. Let's begin. We will start our discussion by looking at what are the different components of a database. A database, at its root, is an organized collection of data stored electronically. It allows users to access data by performing searches that are called queries. Within a database, our information is stored in structured formats, including tables, fields, and records. A database can be used with a standard language called SQL, structured query language, or in formats that do not use SQL, such as document and key value databases. We use databases in our small personal systems, on our own host devices, and in our large enterprise solutions and cloud environments. Database creation is defining the structure of the database. We will create all of the tables that will store all the data, all of the fields that will define different categories and attributes, as well as data types that will be used in the search queries. Database creation can use SQL to create commands within the database, or a software interface with a DBMS, a database management system. In database creation, we will create all the different keys, constraints, and indexes that we use for our data as it's stored within the database. We add new records and information into a database through importing and inputting. Importing is taking files from one location and transferring them into the database. Inputting is the end user manually entering search queries to return some type of output from the database. We want to ensure that all of our imports and inputs have validation. This is having an accurate data set that is consistent across any transfers, and a bulk import will have specialized tools when we have to move and transfer over large amounts of data from one location into our database. We perform searches of records in our database through queries. A query is a request from a user for a specific return of data. Queries can perform several different functions. We can retrieve data, insert a new record of information, delete a record, or update an existing field. Queries use specific commands. A select command allows us to retrieve data. Update allows us to modify an existing record. We also use database reports. Database reports are allowing end users to view database information in a structured format. A report can be visual using charts, graphs, and summaries, or it can be typed in some type of outline or essay format. A database report can be static, which is a fixed data snapshot at a particular point in time. A database report can also be dynamic, where it is constantly being updated in real time. Flat files are simple storage methods of our data in simple text or spreadsheet formats. Flat files are not best if we have a large complex data set, because we don't have any ability for data correlation. Data correlation is the process of identifying patterns or relationships between data and information in separate tables. A flat file will commonly use either a plain text format, .txt, or a CSV file. Flat files will not have any indexing features, so we have to do our searches manually. A database will only be successful if it can handle concurrent users. Concurrency is the process of allowing multiple users to access a database at the same time. We can manage all of our concurrent users and their settings through a DBMS, a database management system. This is a software interface that allows us to view all of the active users in a database and perform any locking transaction processes on individual users. We want to ensure that we have scalability plans if we have an increase of the amount of users. Scalability is the ability of our database to handle an increase in not only the amount of data, but the amount of users. There are two types of scaling, vertical and horizontal. Vertical scaling is adding additional capacity to existing servers. Horizontal scaling is adding additional servers. This will be including additional databases in the entire array. A cloud-based database is going to scale easier than on-premises because the cloud service provider, the CSP, will have more resources available to an increased need in capacity. You want to understand the three common data varieties: structured, semi-structured, unstructured. Structured data are your relational databases. You have tables that allow you to perform identity correlations and relationships using your search queries. Your semi-structured databases use JSON, JavaScript object notation, and XML, extensible markup language, to allow us to perform some standard search queries in more flexible formats. Unstructured data are all of your images, audio, and video that comprise your individual records within the database. These will require special encryption and privacy. A database should also have persistence. Data persistence is allowing our data to be stored indefinitely until we delete or change it. Data persistence should use data at rest encryption. All of our SSDs, solid state drives, and hard disk drives, HDDs, should have encryption. We also want to ensure that we have non-persistent data. Non-persistent data is our memory. When our computer or device powers off, we want our memory to clear. This allows us to free up computing resources and avoid bottlenecks the next time a user is accessing the device. When discussing database storage, there are two common types: cloud and local. Local data is storing your databases with on-premises hardware. All of your data servers, your SSDs, your hard disk drives, they will be within your business's physical location. Cloud storage will be information that is kept on remote servers off-site, and they will be managed by a cloud service provider. Our users access the data over an internet connection to the cloud service provider's resource over the internet. Cloud storage is very scalable. It also allows for remote access as long as we have an internet connection. Your local storage offers you more direct control and better security measures for your sensitive data. And lastly, we will discuss online versus offline databases. An online database is one that is accessible in real time over an internet network connection. Offline data will be stored locally on a host device. The end user can access it without an internet connection. These will be your stored files. Your online systems will have real-time updating and collaboration sharing. Your offline will have data availability if we have some type of network outage. That will conclude our discussion of Section 5.2 database features. In our next episode, we'll move on to Section 5.3 in the objectives and discuss database structures. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.